Welcome to AMAC KSSM channel. This is KSSM at Max Form 5 exercise discussion. I'm Madam Wong here. Everyone, we are in Chapter 6 Trigonometric Functions 6.4 Basic Identities. Our learning objective and success criteria today 6.4.1, students should be able to derive the basic identities. As you can see, we have three basic identities here. Number 1 is sine square x plus cos square x equals to 1. Number 2, 1 plus cotangent square x equals to cosecant square x. And number 3, we have tangent square x plus 1 equals to secant square x. So, students are success if they are able to derive the basic identities with the Pythagoras theorem, unit circle or calculator. Alright? And then our second learning objective here is 6.4.2 prove trigonometric identities using basic identity. So, students are success if they're able to prove some trigonometric identities using the basic identities here. Alright, so let's see. From your textbook, page 211, note that the following basic identities. So we have sine square theta plus cos square theta equals to 1. So the sine square theta here, alright, the sine square theta here means by sine theta squared. Alright, so to simplify the bracket, we can write the square just beside the function of sine. Alright, don't forget to follow by the theta after the function of sine. Okay, so we have sine square theta plus cos square theta equals to 1. 1 plus tangent square theta equals to secant square theta. And 1 plus cotangent square theta equals to cosecant square theta. Alright, so a trigonometric identity is an equation that involves trigonometric functions and it is valid for any values of angles. So as you can see, the theta here is the same. Alright, if you want to make your theta into 30 degree, then this one should be 30 degree. We can check with calculator. Sine square of 30 degree plus cos square of 30 degree. Do you get 1? How do I press this in your calculator? Okay, so we will press sine 30 degree and then square plus cos 30 degree and square, and we should be able to get 1. Alright, so trigonometric identities that we have learned, alright, are as follow. So we have tangent theta equals to sine theta over cos theta, or cotangent theta equals to 1 over tangent theta, or cosecant theta equals to 1 over sine theta, and many more, right? So all these are also identities, trigonometric identities. Okay, so by using a unit circle and a right angle triangle, there are more basic identity which are also known as Pythagoras identity can be proven. Let's see. In your discovery activity 6, alright, we have these two triangles. We have a right angle triangle in diagram 6.5. Okay, so triangle MNP with the right angle at P. Okay. And then we are talking about the angle M, which is theta. So we have M as the opposite, angle P, and side P here will be the hypotenuse, and this is our adjacent, right? So from this right angle triangle, okay, how can we get sine theta? Sine theta is opposite over hypotenuse, so we have M over P, where cosine theta equals to adjacent over hypotenuse, which is N over P. And then let's check out, okay, sine square theta plus cos square theta. What do we get here? For the sine square theta is basically M over P square plus cos square theta N over P square. So the denominator is the same as P square. So numerator, we have M square plus N square. How is M square plus N square over P square equals to 1, right? So as we can see, from the right angle triangle, here, we have Pythagoras theorem, which tells us the p square equals to m square plus n square. Correct? So we can replace the m square plus n square here into p square. So we have p square over p square. And we get 1. So we get proven for sine square theta plus cos square theta equals to 1. So you can try it out with others identity, such as 1 plus cotangent square theta should be equals to cosecant square theta. Okay, and then the tangent square theta plus 1 will be equals to secant square theta. Okay, what about in the unit circle? Okay, we call this a unit circle because the radius is always 1, therefore the hypotenuse is always 1. And then in this unit circle, if this point stop here, right, the angle is theta. We are turning anti-clockwise from the positive x-axis, right? So it stopped here, and the x-coordinate will be representing the cosine theta, and the y-coordinate will be representing sine theta. So, as we can see, okay, from this triangle, okay, we have a Pythagoras theorem, which is sine square theta, the y, okay, plus the x, which is cos square theta, will be equals to their hypotenuse, 1. Okay, so from here, from the unit circle, we also get that sine square theta plus cos square theta will equals to 1. Okay, so this is how we prove, okay, how we derive all this trigonometric identity. Alright, so we get this formula by Pythagoras theorem, whether in right angle triangle or in unit circle. Okay, so we'll move on. As we can see, by using the Pythagoras theorem, it is known that a square plus b square equals to c. So we divide the two sides of the equation by a square, b square, and c square respectively. Okay, so we will get this. Okay, so let's say this is our right angle triangle. Okay, with the side a, b, and c. Let's say this is our theta. Alright, so that from here, our Pythagoras theorem tells us a square plus b square equals to c. Alright, so if I divide everything, okay, by a square, right, a square, and a square, right? So a square divided by a square, we get 1. Then we have b over a square. B is the adjacent, a is the opposite. So adjacent over opposite, we have cotangent square of the theta. And then c over a, which is hypo over opposite, and we have cosecant and then square of theta. Okay, this is how we get 1 plus cotangent square a. Oh yes, this is angle A, so we change it according to the angle A. Okay, so we have 1 plus cotangent square A equals to cosecant square A. Okay, then if we divide into b square, put it on the left. Okay, starting from a square plus b square equals to c square. If we divide everything with b square, and b square. Okay, a over b, which is opposite over adjacent. So we have tangent square of angle A plus b square over b square, we have 1. And the c over b is hypo over adjacent, which is secant. So we have secant square of angle A. So there we get this formula. Okay, so if we divide by the c square, okay, the hypotenuse side, right? So we have a square plus b square equals to c square, which is a over c square, and c square, right? A over c is opposite over hypo, which is sine. Oops, angle A. B square over c square, which is A over H, and then square, we have cosine square of A, and the C square over C square, which is 1. So this is how we get to derive the three identities. Okay, so let's see how do we use the three identities. As in the flipped classroom, okay, teacher has shared you a video about the magic hexagon in trigonometric. Alright, you will see this hexagon. We start with tangent A, and then going clockwise, we know tangent A should be sine A over cos A. Alright, so therefore sine comes first and then followed by cosine. Then the next will come back to the flip of each. Okay, so you will see tangent opposite will be 1 over tangent which is cotangent, and then sine, the opposite will be cosecant. Cosine, opposite will be 1 over sine, which is secant. Alright, this is how we put all the functions in the hexagon. Okay, and as you can see, starting from sine square A, okay, and you go clockwise starting from this point, okay, and then you will form up the sum of the square will get 1. Okay, then we go for the blue triangles. Okay, we start with 1, okay, going this way. Okay, so if I going this way, 1 plus the cotangent square A, I will get cosecant square A. Okay, so I will get this, and then jump another triangle, get the green triangle with the tangent square A going this way, same direction. Tangent square A plus 1 will get secant square A. So this is the trigonometric identities. If you find it is hard to remember this, okay, it is basically, from this. Alright, sine square A plus cos square A equals to 1. How can I get this? Okay, we divide each term by sine square as what you seen in the previous screen. Okay, we are dividing A square, we are dividing B square and C square with different denominator. Alright, we'll get different identities. Right, so let's see. If I divide sine square A, so we'll get sine square A plus cos square A equals to 1. I divide sine square A. What do I get? Sine square A over sine square A, we get 1. And then cosine square over sine square, we have cotangent square of A. You start with CO, then I have CO. Okay, cosine over sine, we have cotangent. Then 1 over sine square, we have cosecant square of A. Oops. So this is how we get the third identity. So with the same method, this time if we divide into cosine square, alright, so from the sine square A plus cos square A equals to 1, and then each term I divide it by cosine square A. Wait, yeah. Cosine square A, cosine square A, cosine square A. I will get tangent square A plus 1 equals to secant square A. Okay, so you will see this here. Alright, so usually we only memorize one. This is the easiest one. And then you derive the second and the third by dividing sine square and cos square each. Alright, so this is how we memorize, okay, or how we remember. So come back to our example 17. Without using a calculator, find the value of each of the following. A, we have sine square of negative 430 degree plus cos square of negative 430 degree. Number 1, check on your angle. We have two equal angle. Both are negative 430 degree. Although this angle looks a little bit scary because of the negative and also more than 360 degree, right? So as long as they are equal, then I'm happy. And then second clue, we have square for the function of sine and cosine. Then check back on your basic identities. All right, so we have sine square theta plus cos square theta. We will get 1 as the theta be my negative 430 degree. All right, I think we missed a square here. Okay, what about B? We have tangent square of pi over 3 minus secant square of pi over 3. What do we get? We have equal theta, all right, equal angle here. And then we have the function with square and square. So we check our basic identity. This is the only identity that involving tangent and secant, right? So from here, if we want tangent to minus secant, which is, I got to switch, right? I need to bring the seconds to the left to be minus. And then the 1, I have to move to the right hand side and become negative 1. Alright, so as long as these two angles is the same, so the tangent square of pi over 3 minus secant square of pi over 3, we will get negative 1. Okay. Example 18. Prove each of the following trigonometric identities, so A and B. Before we prove, okay, check on the excellent tips on how proving to be. Alright, so to prove the trigonometric identities, prove from the more complex side. Okay, if you notice, okay, many of your mathematics question always ask you to simplify. We are always teach to make things simpler, so we do simplification, right? So if we start from the complex side, then we have more chance to simplify things. Alright, then B, convert the basic trigonometric ratios form. Okay, so basic trigonometric forms will be tangent theta equals to sine theta over cosine theta, or cotangent theta equals to cosine theta over sine theta. Okay, and then choose from the identities. Then C, multiply by a conjugate if required. What do you mean by conjugate? Okay, let's see. We have A plus B. Alright, the conjugate of A plus B will be A minus B. This is the conjugate. Okay, so that we can get an A square minus B square. Okay, so if you are starting from the more simpler side, you have to times the conjugate. Alright, usually. Okay, or if you have something like this and you get only A plus B, then I know I need to times the conjugate so that I can reach the A square minus B square. We'll see later. Alright, so for A, 1 minus 2 sine square A equals to 2 cosine square A minus 1. So we have square of the function of sine, square of the function of cosine. So it's the same complex for both sides. So we can start from left or start from the right. Okay, about the left and right, the equal sign, all right, the equal sign break our equation into left hand side and right hand side. So we'll use short form LHS as left hand side. Okay, and the RHS will be right hand side. Okay, so if we start from the left hand side, okay, we get 1 minus 2 sine square A equals to, check on your right hand side. You want only function of cosine, no more sine, right? So check out the basic identities here. This is the only basic identities that involve sine square A plus cos square A equals to 1. So if I want to change the sine square into cosine square, alright, so I got to shift the cosine square become 1 minus cosine square A. Alright, therefore you get this. Okay, we replace the sine square A by 1 minus cosine square A. So expand the bracket and simplify, you will get 2 cosine square A minus 1. So exactly the same as what we required. So hence it's proof that 1 minus 2 sine square A equals to 2 cosine square A minus 1. Then we check on B. Tangent A plus cotangent A equals to secant A times cosecant A. What about tangent A plus cotangent A? Okay. We will start on the left. Why? Because we can change our tangent A into sine A cos A. And then the cotangent A is the flip of tangent. So we get cosine A over sine A. Right? So now you will see we have two fractions plus together. Okay. So the denominator is different. So to make the denominator same, we have to times, right? Cosine A, the first fraction, I need to times sine A. Up and down of the fraction. And then for the second fraction, cosine A over sine A, to make the denominator same, I need the factor of cosine A. So I times cosine A for up and down. Now we can see below we have sine A cos A for both fractions. So we can just write 1 cos A times sine A as the denominator. About the numerator, sine A plus sine A times sine A, we have sine square A. And then cos A times another cos A, we get cosine square A. Oh, we have same angle and we have the function in square, so we can check on our basic identities. We have sine square A plus cos square A equals to 1, so we basically have 1 over the denominator, which is cos A sine A. So from here, we can break our fraction into 1 over cos A times 1 over sine A. Okay, and we can see 1 over cos A is actually cosecant A, and 1 over sine A is actually cosecant A, and times, therefore I don't need any symbol in between of secant A and cosecant A. Okay, hence it is proven that tangent A plus cotangent A equals to secant A times cosecant A. Okay, move on. Example 19 in page 213. Prove that tangent square x minus secant square x plus 2 equals to cosecant square x minus cotangent square x. Alright, so if we have to prove, okay, we can start from both left or right. Okay, up to you. Okay. As your textbook, you start from the left. We want to change the tangent and secant into cosecant and cotangent, right? But we can see tangent minus secant square x, tangent minus secant square x. Okay, we will get tangent x minus tangent square A minus secant square A. I will get negative 1. Therefore, you replace this by negative 1. And then plus 2. Put back plus 2. So negative 1 plus 2, we get only 1. And from this one, it is hard, okay, to think of how can I get cosecant square x minus cotangent square x. Therefore, we start from the right. Okay, check on the cosecant square x minus cosecant square x. So cosecant square x from here, okay, 1 plus cotangent square x equals to cosecant square x. Okay, so the cotangent square x is actually, cotangent square x minus cosecant square x minus cotangent square x. I shift this to be minus, so we have cosecant square x minus cotangent square x, and I will get 1. Alright, so from here we can straight away change this into 1. Okay, we don't need to do as the textbook. Okay, of course you can follow, but this is a longer way. So we can see from the basic identity cosecant square minus cotangent square x, I will get 1 as well. So the left hand side, I get 1. Right hand side, I'll also get 1. Therefore, we can say tangent square x minus secant square x plus 2 equals to the cosecant square x minus cotangent square x, because both are equals to 1. Okay, so we'll discuss self-exercise 6.3 in the next video. Thank you.